$12 setup went viral for doing something seemingly impossible, harvesting clean drinking water straight from thin air, using nothing but garden mesh and PVC pipes. It's a genius concept based on ancient principles of physics. But if you simply copy this tutorial page by page, you are ignoring a critical engineering flaw that wastes up to 50% of the water before it ever hits your cup. Today, we are going to break down the science behind the fog harvester, how to build it, and the secret trick to double its efficiency without spending another dime. Watch closely. Water dripping slow and steady into a container, as if it had been doing so all through the night, because it was. No pipes, no well, no rain in the forecast. 4 days of drought, and it still worked. This video circulated everywhere. Thousands of people watched it, thought it was brilliant, and moved on. The problem is, most people applied exactly what they saw and got a fraction of the results they should have, not for lack of effort, but for lack of one piece of information that the original video simply doesn't deliver.
The principle is real and has over 100 years of documented history. Fog harvesters, dew collectors, technologies applied in coastal villages in Chile, the mountains of Morocco, and rural regions of Ethiopia, where there is no infrastructure, no power grid, and the water tables have run dry. It works. That is not up for debate. What is up for debate is why most homemade replicas collect far less water than they are supposed to. The surrounding air carries invisible, suspended water. There is a temperature called the dew point. When the air touches a surface at or below that temperature, the vapor condenses, becomes liquid, and begins to run down. The original project captured this principle correctly. A large surface area, oriented into the wind, tated so that gravity guides the drops down to the collection point. So far, so good. The mistake lies in a detail that no standard tutorial mentions, and it appears exactly at the moment when the system should be working at its best. No moving parts, no energy consumption, no maintenance. The system is set up before bed and operates autonomously all night long. And here is the data point that changes your entire perspective on this. Earth's atmosphere contains at any given moment approximately 37 million billion gallons of suspended fresh water. More than the sum of all the rivers on the planet, floating, invisible, accessible, and almost no one is collecting it. That is the core principle of the project. Now, here is the materials list to make this water collection system 3 times more efficient. A shade cloth, 6 by 6 feet, the kind you find at any garden center or hardware store, for about $5. The tighter the weave, the better. Your goal is something closer to a window screen, not a volleyball net. The mesh is the component that does all the heavy lifting of capturing the water. And this is exactly where most people make their first wrong choice without realizing it. The rest of the structure, 4 sections of 1-inch PVC pipe for the frame, $2, or less if you use scrap material. Plastic zip ties, a plastic gutter to serve as the collection trough, $3 to $4. A few bricks or stones to adjust the angle.
Total between $10 and $14. If you already have zip ties and stones on hand, the cost drops to $8. No specialized tools required. The PVC cuts, when needed, are usually done for free right at the hardware store. Assembly begins with the frame. 4 sections of PVC forming a rectangle, approximately 4 feet high by 3 feet wide. The goal isn't aesthetic precision, it's structural stability to withstand the wind. Zip ties at the corners solve it without the need for fittings. The mesh is then stretched over the frame, tight, with no slack, and secured with zip ties every 6 inches along all edges. The original video stops here in the assembly stage, and it's understandable. Visually, the project looks complete, but there is one variable that determines whether this collector will actually produce water through the night or just accumulate moisture that vanishes with the morning sun. And it's not in the structure. It's on the surface of the mesh. The correct reference for the tension of the mesh is that of a drumhead, uniform across the entire surface. Slack mesh means water pooling in low spots, and pooling means slower runoff, in theory.
because there is a phenomenon that happens before the runoff, one that makes this tension issue more complex than it seems. This will become clearer in a moment.
For now, the tilt angle, between 15 and 30 degrees from the vertical, as if the frame were leaning slightly against a wall. A flat position is the most common mistake in first-time builds. Water pools on the surface. The morning sun evaporates it all before collection, and the result is close to zero. With the correct tilt, every drop formed on the mesh travels by gravity to the bottom edge and drips directly into the gutter position below. A hose extension from the gutter to a storage container is optional, useful for volume, but not necessary to validate that it works on the first night. Placement is where most people lose efficiency, without realizing it. The frame must face squarely into the wind, not sideways, not backward. The goal is for the air to pass through the mesh, not deflect around it. The correct procedure is simple. Walk around the area at dusk and identify the prevailing direction of the breeze. That is where the front face of the frame should point. Elevation matters too. Even 1 foot above the ground makes a measurable difference. The air right next to the ground is drier and warmer than the air at slightly higher elevations.
Finally, morning sun exposure. The collector must be positioned out of the path of the early morning sun. The goal is to preserve the harvest formed during the night until the moment of collection, not lose it to evaporation before you even wake up. All of these variables, angle, orientation, elevation, shade, are correct in the original project. They are well-founded installation decisions. The problem is not with any of them. The setup is done before sunset. The collection happens at dawn. That's the entire routine. What occurs during the night is just physics operating the way it always does. As the temperature drops, the air in contact with the surface of the mesh cools along with it. Upon crossing the dew point, the vapor has nowhere to go. It condenses, forming a droplet. That droplet meets another one nearby. They fuse, gain mass, and gravity does the rest, running down into the trough. On the first night of operation documented in the original video, average humidity, temperatures around 53 degrees Fahrenheit, 12 degrees Celsius, no fog, no rain. The result was just over half a liter, which seems modest until you consider that the conditions were absolutely ordinary.
Nothing special about that night. In humid climates, coastal zones, river valleys, regions with morning fog, records point to 1 to 2 liters per night with a structure this size. Scaling the mesh up to 10 by 10 feet, daily production starts to become significant. Enough water for a family's consumption, built in an afternoon with materials from a single hardware store. Here is what standard tutorials fail to mention, and the reason why many of these replicas produce less than half of what they should. Fog microdroplets are extraordinarily light. When they hit a standard plastic garden mesh, they get trapped by surface tension, an invisible force that makes water stick to surfaces. Instead of running down into the gutter, these droplets remain suspended on the mesh until the morning sun rises, and then they evaporate right back into the air. The entire night's harvest simply lost. The solution isn't in the structure, the angle, or the orientation. It's on the surface of the mesh, and it's simpler than it looks. The mesh needs to be treated to repel water instead of retaining it. The process has 2 practical options. The first, and most direct, is to apply a hydrophobic waterproofing spray, the same kind sold to waterproof shoes or outdoor gear, found at any sporting goods or hardware store.
Just spray it over the stretched mesh, wait for it to dry completely, and install it normally. The second option, even more accessible, is to use silicone oil or light mineral oil, products sold at drugstores and hardware shops. Dilute a small amount in isopropyl alcohol. Apply it with a cloth or a spray bottle across the entire surface of the mesh and let it dry. The result is equivalent. In both cases, the effect is the same. Surface tension is eliminated. The instant a microdroplet touches the treated surface, it beads up and runs down immediately, without resistance, straight into the gutter. The system doesn't just collect water, it optimizes it. And this treatment, which costs less than $2, can double the volume collected per night. Regarding consumption, atmospheric water is, by nature, relatively clean. It hasn't touched the ground, hasn't run through pipes,
and doesn't carry what makes surface water problematic: bacteria, agricultural runoff, or heavy sediments. Even so, it can pick up particles from the mesh over time, or traces of pollutants in urban environments close to heavy traffic.
The filter takes 5 minutes and costs $3. A plastic bottle with the bottom removed, inverted with the neck facing down, layered with materials: cotton, activated carbon, fine sand, and a final layer of cotton on top. The collected water passes through the top and comes out filtered through the neck. For additional safety, boil it, or add 1 drop of unscented household bleach per liter, and wait 30 minutes. The result is equivalent to treated tap water. Honestly, probably superior, depending on where you live. This knowledge is nothing new. The Incas built stone structures specifically designed to condense water from mountain fog. In the Canary Islands, fog collection nets have been working for generations. There are Bronze Age structures in the Negev desert that archaeologists now interpret not as reservoirs, but as collectors, built to produce water, not just store it. At some point over the last 100 years, as indoor plumbing became the standard, this knowledge simply stopped being necessary. The tap worked, and what worked without effort was forgotten.
$12, an afternoon. And that knowledge is practical once again. With one extra detail, the mesh treatment. What already worked begins to work significantly better. Now, I don't know what your situation is or why you are watching this. Maybe you are thinking about prepping for a potential grid collapse. Or maybe you just like building useful things. It could be that you stumbled onto this video at 3 a.m. and you already feel the urge to build your own water catchment system, because this truly is useful. It doesn't matter. It works either way. And since you made it this far, clearly, you are not the type to settle for ready-made answers. Let me show you something that pairs perfectly with what you just saw. How to make fire using carbide stone and water in a bottle. Simple, portable, without relying on anything you can't easily find. The kind of thing most people will never know, but you will. Now that you know what to do, save this video for when you build it. Stay safe, and see you in the next video, right here on Miller Solves.